Think of a train. Each coach is connected to the next, forming a line. This is the perfect way to imagine a linked list. A linked list is a data structure made up of nodes. Each node contains two things, the data and a pointer to the next node. This chain of nodes lets us store and organize data in a flexible way. Let's break it down visually. Imagine 4 nodes labeled A, B, C, and D. Each one connects to the next using a pointer. So A points to B, B to C, and so on. The last node points to nothing. We call that null. This is called a singly linked list. We can only move forward, one node at a time. Want to go backward? That's where doubly linked lists come in. Here, each node has 2 pointers, one to the next and one to the previous. Then we have the circular linked list. Instead of ending in null, the last node points back to the first. It forms a loop, great for things like playlist queues or round-robin scheduling. Let's take a real-world example. You're managing your daily tasks. Each task is a node. You finish one, and it points to the next. If you cancel a task, you just update the previous task to point to the one after it. You don't need to shuffle anything, just relink. Insertion and deletion in a linked list is efficient. Say you want to insert a node between B and C. All you do is point B to the new node, then the new node to C. That's it, no shifting like in arrays. But linked lists have limitations. Unlike arrays, you can't instantly jump to a specific item. To get the 5th node, you have to start from the beginning and follow the chain. So when should you use a linked list? When data is constantly changing, when you need to add or remove items often, when you don't know the final size of your data set. You'll see linked lists in file systems, music players, image galleries, even undo-redo features in software. They're dynamic, memory efficient, and built for flexibility. That's the power of linked lists. Not just a train of thought, but a train that adapts, grows, and moves with your data.